All right, so in this one, a middle school wants to fence in 3 equally spaced areas, one for each grade, all right, for students to play outside during recess. They have enough in the budget for only 500 feet of fencing, and they're building it against the school, as shown in the figure. What should the dimensions be of a play space? So, like one of these smaller rectangles, what should the dimensions be, meaning like the length or the width, designed for one of the grades in order to maximize the area? No fence is needed right against the wall of the school. All right, so we don't need any fencing down here. You want to maximize the area. All right. So personally, I like my students free range students. I don't like them caged in like this, but that's what the question says. So we have two variables, which tells me we want to come up with like two relationships. So one of them could be the total fencing that we have. So there's 500 feet of fencing, and it's made up of these 7 parts. So 3 of the parts have length X, and then we also have 4 of the parts going this way. 1, 2, 3, 4. And I got a splinter. That's annoying. I gotta get that later. Sorry. Plus 4y. I was wondering why my hand was hurting me. All right, so that's one relationship between x and y. All right, another one would be the area. All right, so the area of like one of these is going to be x times y. Now, to maximize the area, um, it helps to come up with a function in terms of one variable. So we can use that top equation to write the area just in terms of x or just in terms of y. And then once we have the area in terms of x or y, then we could graph it and look for the point where the biggest area. So if you take this um, and solve for, let's say, y, you would get y is equal to, so you'd subtract 3x on both sides. So you get y is equal to 500 minus 3x, right? And then divide by 4. All right, and then you could plug that in there for y, and then you'd get the area just in terms of x is equal to x times this right here, 500 minus 3x over 4. So I know this, the x is from right here. Like x times y, it's this side times this side gives us the area of the rectangle. Length times width is the area of the rectangle. So one x represents this side, and then 500 minus 3x over 4 represents this side because remember it was equal to y. Does that make sense? So it's the same. So the area is x times y, like base times height. You're saying like where this x comes from? All right, cool. All right. Yeah, and then we just replace y with y in terms of x. So now it's just, so now we can graph this and we'll know what the area is. That'll be the y coordinate in terms of x, which is this specific dimension in the picture. So you could graph it or not graph it to find the maximum because the maximum is going to occur at the vertex. So you could find the vertex without graphing it, but so it doesn't matter how you do it. You can use a calculator. So you might as well graph it. So we're going to get x times 500 minus 3x and then over 4. And then this graph represents the area in terms of x, but it's a little zoomed in. So we're going to have to zoom out until we see the whole parabola. And now we see it. And it's quite big because the area is quite large with respect to what the original units were on the axis. And then when you zoom out like this and you want to zoom back in, but cut out a lot of dead area, like all this white space is like kind of dead area. We don't really care about it. Question. We could just box in the part of the graph that we want. All right, now we see the whole parabola. So now if we did analyze graph maximum, we could see that, all right, when x is 83.33, that's the biggest possible area we can get, which is around 5,200 square units. So we in back to plug back into the context of the question, we want the dimensions to be 83.3. All right, and then same thing for the other two x's. And then for y, remember, we could plug in x into, yeah, we could plug it back in. Yeah, right, exactly. So 500 minus 3 times, exactly, uh, this divided by 4. And then that, because I'd done this problem earlier, I kind of remember the answer. That comes out to 62.5. So the dimensions to maximize the area would be like 83.33 by 62.5. And then y is, because we know y, we know that the total fencing is 500. So if you subtract what this is, so 83.3 times 3, subtract it from 500, and then, and then there's 4 of these left. Right, because then you'd have 250 left, but you have to distribute that to 4 sections. Cool. All right. So let me end this.